Okay, we are now on part 3 of lesson 12.6. This is the last little bit. We're just going to do a couple more examples. We're going to do a couple special cases so you can see that things don't always turn out the way we want. So we've got our examples from above. Now we're going to take a couple more linear equations. X plus 2y equals 2, negative x minus 2y equals 1. And again, we're going to set these up as matrices. So we've got 1, 2, negative 1, negative 2. That's our matrix. And that would be multiplied by x and y. And that would equal 2 and 1. Now, if you input this into the calculator and try to find its inverse, you'll find that it gives you an error message. There's no answer. And the reason for that is if we're trying to find the determinant, remember the determinant we calculate by taking a times d minus b times c. Well, if I do that, that means I've got negative 2 times 1, and then I've got 1, negative 1 times 2, and that means I'm going to end up with negative 2 minus negative 2, which equals 0. And that's going to give me a denominator of 0 for my determinant. And therefore, this is no solution when that happens. So we can actually solve for x or y. Go on to another example here. Got x plus 2y equals 2, 2x plus 4y equals 4. Again, we can set up our matrix, 1, 2, 2, and 4. And then we have x and y. And that equals 2 and 4. And again, we can see 4 times 1 is 4. 2 times 2 is 2. That's 4. So if this is 4 and this is 4, those cannot equal each other. And again, we're going to have no solution to that. Okay. All right, last. Now we have 3 equations that have 3 variables instead of 2. We have x, y, and z, but this is still can be set up as a matrix. It's just going to be a little bit bigger. Now we're going to be dealing with a 3 by 3 matrix. So we've got 3, negative 1, 2, and then 2, negative 3, 1, and then 1, 1, 1 for all the numbers that would be in front of those variables, times x, y, and z, and that would equal 12, 4, and 6. And now all I really need to do is I can find the inverse of this matrix. And when I do that, if I take the inverse of this, I'm going to get 4, negative 3, negative 5, 1, negative 1, negative 1, negative 5, 4, and 7, and then multiply it by the 12, 4, 6, and that's going to give me x, y, and z, which if I do that, I should get 6, 2, and negative 2. And again, we can double check to see if these actually check out. For example, if I take 6, put in for x, and I put 2 in for y, 6 plus 2 is 8, minus 2 gives me 6. And I can do it for the others as well. 2 times 6 is 12, minus 3 times 2 is 6, so 12 minus 6 is 6, plus negative 2 is 4. So they'll check out, and they work quite well. You can do this with varying sizes as long as we have enough variables to make a 2 by 2 or 3 by 3 or 4 by 4. It all works out.